First, we're going to investigate probability. Instead of looking at the rules and laws and how we use the formulas for probability, we're going to simulate probability, such as the last example, by flipping a coin over and over and over again to see, is it truly 0.5? Well, by simulating it, we could flip the coin over and over and over again and see that, yes, it's eventually over a many flips, it starts to approach that true answer of 0.5. However, flipping a coin 100 times or 500 times or 10,000 times is not very realistic, very time consuming, and not the best way to go. So instead, we are going to simulate flipping a coin. We are going to simulate rolling a die or whatever it is that we're trying to answer. Okay, so for a probability question on the AP exam, if you forget how to do the formula or you're not able to make the calculations or computations, you can set up a simulation and do the problem that way. Okay, simulation is the imitation of this chance behavior. We have to set up a model, however, by assigning random digits like we did in Unit 4 to certain outcomes. And then we can use our calculator, we can use the random integer command, or we can use the random digit table, or what our book will refer to as Table D, which will also be in your formula packet for the AP exam. So how do we set up this simulation process? Okay. So we are going to describe how we are going to use chance to imitate one trial. So we have to explain what it is that we are going to do. Okay, what constitutes one trial of this simulation? Then we'll perform many trials, and then we will use the results from those trials to answer the question of interest. So, for example, I know that the probability of rolling a 3 is 1/6 or 0.16 forever. Let's simulate rolling a die 10 times. I'm going to say that the number 1 equals getting a 3. The numbers 2 through 6 equal not a 3. So if I wanted to run this simulation 10 times, I could come to the random digit table and say, yes, I got a 3. Nope, the 9 doesn't count because it's not a number between 1 and 6. So my first roll, yes, I got a 3. My second roll, nope. Third roll, no. Fourth roll, no. 9 doesn't count. 5, that's not a 3. 0 doesn't count. 3, no, that's not a 3. 4, nope. 0 doesn't count. 5, nope. I've done 1, 2, 3, 4, 5, 6, 7, 8. 7 doesn't count. 9, 10. So in my simulation, I have the probability of rolling a 3 as 1 out of 10. Now, is that the same answer, 0.1, as the true answer of 0.1666? No, because this was not enough trials. We didn't run this enough times to come up with the true value for the true probability. And we may never find the exact true probability in a simulation. However, the more trials that we run, the closer that this simulation would come to the true answer of 0.16. Let's run 10 more and combine the two and see what happens. A 2, nope, that doesn't represent me rolling a 3. 7 and 8 don't count. 1, yes, it does. 3, no. 9 doesn't count. 6 is no. 4 is no. 0 doesn't count. 9 doesn't count. 1, yes. 2, no. 5, no. 3, no. 1, yes. Okay. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now I've run 20 trials, and I had on my 20 trials, the probability, my simulated probability of getting a 3 was 3 out of 20, which is 0.15. Now I'm starting to get closer to the true probability of 0.16. So the simulation here that I'm running, as n gets larger, the number of trials, as I do it more and more times, my experimental probability that I'm getting from running this simulation starts to approach the true theoretical probability. And if I were to run more, I would probably get closer to 0.16666. And I would get closer again to 0.1666 as I went through this process over and over and over again. Now we can set up a simulation for any probability of any subject that we want, whatever the case is. For example, the probability that you are a sophomore in my class is 3%. The probability that you are a junior in AP Stats is 21%. And the probability that you are a senior in AP Stats would be 76%. So now I would need to assign random digits to these outcomes. For example, I'm going to say being a sophomore, that gets the numbers 0 to 2. That's 3% out of 100. I'm going to say the probability of a junior, or the random digits that align to being a junior, would be 3, and I need 21 digits here. So it would be 3, not to 24, but to 23. And then 24 to 99 would represent being a senior. Notice here that I started with the number 0 and I went to 99. If I'd started from 1, the numbers would have had to have been 1 to 100. And remember, as we talked about in last unit, if I'm going to pick 3-digit numbers, then all the numbers have to be 3 digits. So if I had done 001 to 003, or to 003 for sophomores, and 004 to 00 or to 024 for juniors, and then 025 to 100 for seniors, why would this method here not be very useful? Well, I'd have to look at 3 digits at a time. The first 3-digit set is 192. Well, 192 doesn't count. It's not part of this. The next 3-digit set would be 239. Nope, doesn't count. I've already looked at 6 digits and have yet to find one value that's going to be useful for me. The next number, 503. Nope, that doesn't fit between 0 and 100. 450. Nope, that doesn't. 756. Nope. 287. Nope. 139. Nope. 640. Nope. 912. Nope. 531. No. 425. No. 448. No. 285. No. I've used a whole line and have yet to gather one valuable data point. So if I use this combination over here, where I labeled them from 00 to 99, well, the first one, 19. Number 19, oh, that's a junior. The first kid that I simulated was a junior. So was the second kid, junior. 39, that's a senior. 50, senior. 34, senior. 5, junior. 75, senior. 62, senior. Every single digit in this would be something that's useful for me in my simulation process. So if we are looking out of 100, instead of using 001 to 100, we want to use 00 to 99, just to make this random digit table easier to use. So we could simulate any probability question in the world using the random digit table. Now, if we use technology for simulation, it doesn't matter what digits we start with, because the calculator can handle that for us. So for example, I want to choose 10 students, and let's see if this experimental probability using simulation will be close to the theoretical probability. I know that 3% of all students who take the AP class are sophomores, 21% are juniors, and 76% are seniors. So to simulate this, we need to go to random digits. So if we go to math, probability, rand int. I want it to generate digits between 1 and 100, and I would like it to generate 10 digits, and I'm going to paste it. Now, I don't want to have to scroll through and look at all these, so I'm going to store these 10 digits in list 1. But I don't know if I already have other numbers in list 1. So I'm going to go into list 1 before I put these randomly selected 10 digits and make sure that list 1 is cleared out. So if you go up to the top and highlight L1, and then you hit clear and then arrow down, it will empty everything out of list 1 in one fell swoop. Otherwise, if you wanted to do it this way, you'd have to click on each one and then hit delete, 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 delete until you've done that for every one. Instead, go up to the top, hit clear, and arrow down. Okay. Now, this is very common. Students will go up here to number 3 and they'll hit delete. Uh-oh, my entire list 3 is deleted. It's gone. If that happens, no problem. We can get the list back. We go to Stat, Setup Editor. Whoops, let me clear this other stuff out. So Stat, Setup Editor, enter, and it will say done. Now when I go back into my lists, wow, magically list 3 reappeared. So if you accidentally delete a list, no worries. You can go back and get it back by using Setup Editor. So I'm going to clear out all my lists before I run this simulation. So I'm going to come back to math. Whoops, I don't want to be in here. I want to be in my main screen. I'm going to clear it out. So math, probability, random integers. I'm going to ask the calculator, please give me random numbers between 1 and 100. And I want 10 numbers. And I'm going to, 1 to 100. I want 10 of them, paste. And then I would like to store those in list 1. Now, if I go back into list 1, I have the 10 randomly selected integers between 1 and 100. Now, it might make it easier if I could order these, because I need to see how many of these are freshmen, or how many are sophomores, how many are juniors, and how many are seniors. So if you go to Stat, and instead of going to Edit, if I go Sort A, which means ascending order from smallest to largest. So I'm going to ask the calculator to sort that list for me and put them in order from the smallest number to the biggest number. Calculator says, cool, I'll do that, but what list do you want me to do? Oh, would you please sort list 1? And then I hit enter and it says, okay, I did it for you. Now, if I go back into my list, it put them in order. So it randomly selected 1, 1, 11, 23, and so on. So it selected 2 students that were sophomores and 2 students who were juniors and 6 students who were seniors. So from my simulation of 10 students in my class, I ended up with 20% sophomores. I ended up with 20% juniors, and I ended up with 60% seniors. Now, was this simulation equal to the true probability? It wasn't even close. Why not? Because the law of small numbers does not work. If I were to do this over and over and over again, these probabilities of 20%, 20%, and 60% would start to get closer to the true probabilities of 3%, 21%, and 76%. So simulating is going to be something that you're going to get comfortable with lots of practice. It's going to take a while before this becomes natural for you.